So I looked online and tried to find information on the motor wiring and switch, and it basically says all of that, which you can pause if you want to read. And then it says here's how to wire a three-phase switch up at the top, and here's how to do it in single phase, and here's how to do it if it's 220 volts. So that's all great, but that has multiple colors, and on mine it doesn't actually, well, it didn't actually have multiple colors. It just had 3 tan on the bottom and it had 3 black on the top. So then I thought, okay, well, how am I going to figure this out? And it's like, all right, well, I will get my multimeter, and it's a Fluke 117, and it has this tone section. And if you're in the tone section, what that does, if there's continuity, or a path for the stuff, it will tell you. And if there isn't, it will tell you that too. So then I thought, okay, well, that's great. I can just test all of the six things on here. And then I did that. And when I tested the top and bottom, I don't know if I can do this with one hand, because previously I tried this with 2 hands, but I wasn't filming. So let's see if I can do this. So with it off, there is no signal for that pair, no signal for that pair, and no signal for that pair. And then similar with a regular light switch, when it's in the off position, there's no signal, which means there's no path. So if I turn it on, so there's a path. So then I figured, okay, well, I will turn this one on instead of off. And then, again, assuming I can hold this right, with it on, there's a path from top to bottom, path from top to bottom, path from top to bottom, but no path on the other combinations. So what that made me figure out is, and then I thought about it, it's like, okay, if this was set up for 3-phase, 3-phase means you have 3 hots, if I'm remembering correctly. 220 has 2 hots, which would correspond to this diagram. 3-phase would have, 3 coming in from the line, black, 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 red, red, red. So that's somewhat similar to black, 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 tan, tan, tan. 220, it would have 2 lines coming in and 2 going this way, but that one goes to the switch and one goes the other way. So I think what this is there are 3 inputs. I'm not 100% sure if it's at the top or the bottom or if it matters, but there's 3 inputs and then 3 outputs, so all switched. So I effectively have 3 switches here, but with 1 button, which is kind of cool. So that should give me enough information on how to actually try and wire it up. So now I just have to, well, I'm going to go look at my other drill press and see how I have the switch wired there, because that one, unlike this one, that one came in as single phase. So I just had to reconnect everything back up with single phase. So I should be able to look and see how the switch is wired, and then just use one of these, one coming in from the hot, one going to the switch, the other side from the power coming in going to the other side of the motor, and then so forth. So that should let me get this working. Well, I was able to get the pulley off the old 3-phase motor, and I got the motor key out. And I ended up using a 5/32 wrench on that take out the key or the little the retention screw, and I was able to work it up off with some WD-40 off the old one. Got it on the new one, and then turned this over and realized, oh look, the 1 horsepower motor has a motor mount corner missing on the cast iron bit. So that's not ideal. It's an old brake, so it wasn't something that happened recently, but I didn't notice that part. So I'm not sure how well that's gonna hold or be uneven. But with here, there's just 3 wires on the big motor. So I have no clue how to wire that. I don't know if that just goes directly to the 3 hots or how you wire a 3-phase. And I'm still not 100% sure on how to wire this one. Still have to work and figure all that out. But the biggest annoyance is I hadn't realized that was broken. I mean, it's already a different shape than this motor, so getting it attached is going to be hard enough, but only doing it with 3 mounts versus 4. So one of the things I noticed when, and I don't remember if I videoed this yesterday or not, I had the single phase motor attached on here through this hole, just holding it on, and I lined it up with the bottom pulley on the front and on the back, and it's not lined up now, but I had it lined up the other day. And in order to get it clear down to there, which is about the same distance going across, you kind of see it that way. In order to have it like that, I can't have the motor up this far. I have to have it down further. So what that means is none of the 4 hole, like initially I thought, well, maybe if I drill out in this direction over here slightly, then these holes would match the holes in the mounting bracket. However, because the motor has to be shoved down, I would have to drill 2 holes here in the plate and then 2 other holes and then somehow space it up and, you know, keep it level and everything. And it's like, that's too much work. The big reason is I don't have a good way to hold this mounting plate, which has a curved backside, on my drill press to be able to drill through straight. But I did get at Home Depot a piece of this, and I was able to use this, which is much better than initially I was going to use a hacksaw because I don't have one of those fancy metal bandsaws. But then I was like, wait a second, I bought a thick steel blade for this that'll do 3/16 to 9/16, and it'll do cast iron, high strength alloys, and stainless. So that means that, you know, since it has carbide teeth, that should cut through plain steel just fine. And it did. About the time it took to clean off the bench to get the area around the vise set up, I had 2 pieces cut off. So now the plan is, so I'm going to put this on both sides and then drill holes to hold this to the mounting bracket, and then drill in tap, or 3 holes. There's only 3 holes in the mounting plate on the motor. So, and then I can do 3 holes drilled and tapped in this 3/8 inch steel, and that should be plenty to hold that on. At least we're going to try it. And I also ordered, since this is a 4L600, I believe that means this is a 5-foot belt. Well, unfortunately, even without this spacing, for whatever reason, when I put the single phase motor on here, it is jammed up clear into the paint with this mounting plate being shoved into the motor, meaning it's the whole way in, and it's still too tight to put the motor flat on the mounting plate. So I ordered some link belts as replacements, and so I'm going to just replace this with a link belt. And I also noticed that it is extremely dusty and dirty back in there. I got some of it out, but I'm going to have to clean all this out in there. I'm not sure if I'm going to have to take it out completely to clean it all out. I'm going to try and leave the assembly in there because otherwise I have to press out the bearings and everything else. I'd rather not do that until I know I have to replace the bearings, and I can't tell that until I get the motor installed. Can't do that until I get the link belt. The link belt should come tomorrow. So I'm going to see how much progress I can make with drilling holes in this and at least fixing it to the plate, and then exact holes where the motor should go. That way I don't have to drill into the mounting plate and try and, again, I don't have a good way to hold that with the drill press setup that I have. I'm going to have to use the Rockwell drill press that I got with the cross-slide vise to do these holes, but that should work fine. Well, that worked. It actually worked really easy on the Rockwell drill press to drill those. Yeah, that'll work good. Now I have to try and I'm going to hold the single-phase motor up and see if I am correct that the motor mount goes below this. If the answer is yes, then I can move forward to try and hold it and figure out where those holes are supposed to go and then go from there. If the answer is no, then I have to figure something else out. And since I have to wait on the belt, put a plug on my cord. This is a 12 gauge cord that I got. Should be good. Okay, well, with figuring out how to put that on its front, and blocking with some 204s and blocking it with the cabinet that was for the old electric, and taking the washer out and sliding it the whole way up and sliding the pulley up. You can see that little lip. I slid it up that far and then retightened it. And with the link belt and with this the whole way in, which I'm still not 100% sure I want it the whole way in, but that's okay. I have more link belt. I can extend that if needed. But given all that, that looks parallel. That looks, other than the link belt not being super tight, it looks like this distance here is the same as this distance here, and that's what you want. You want this to run in a plane, not tilted, because if it's tilted it's going to wear and tend to want to pop off, which is not ideal. So I think this will work. So now what I'll do, because this is just balanced here, don't touch it, it's balanced. So now what I'll do is I'll get it centered right and left, although this will slide right and left, so that'll be fine. I will make a mark with a Sharpie down in there on the steel, and then take that over and try and drill and tap for that, because at this point any adjustment that vertically should be possible just by moving the pulley back and forth on the shaft, because this is really close. All right, so there's the one mark, there's the other two marks. Now I get to go drill and tap that and see how that goes. So I have the DWA 1452 tap and die set. That does 1/4 20, 5/16, 18 threads, 3/8, 16, which is what I need. So I used the drill bit for that and drilled one of the holes. And then carefully tap down in, and it goes down through. So now I just do 2 more and then see how well it works. Good news. A 3/8 bolt with a lock washer, 2 of those washers that look like that, ends up being pulled down tight against this, and if I manage to get it underneath, it is not coming through the bottom. So what that means is it's tight, but it's not impacting the green casting part. So that means this is pulling tight onto here, which should be good. And so that's, oh, if I can hold it correctly, it's pulling down about that far. So that's pretty much right to the bottom. Not quite. There's like 1 thread from the bottom. I know my fingers are in the way, but so that's awesome. That should be plenty of holding power, all but 1 thread. So that's good. And so now I just got to do something similar on these 2 sides. Hopefully that'll be really good, actually. Of course I got to take it back off. Well, no, I can just take this off. That's the one benefit of having it on this mounting plate, is I can just loosen a screw and this whole thing lifts off. Although this is not gonna be able to, yeah. Anyway, I gotta take this back off before I do much, because this motor plus this mounting plate plus the head casting is too heavy to move around by itself, or all together rather. It's okay to do this by itself and these two by themselves, but altogether is not convenient. But this is awesome, and that'll go in and out easily enough with a wrench. So that's just a 9/16 wrench on the 3/8 inch bolt, and that's great. So, yay! Like I said, that looks pretty flat. So I don't know that the belt is tight enough because it has a lot of give to it, but I think it's straight. So I think that's gonna work. Okay, we have a plug. We have a cord. We have a cord that goes into this little box. We have wires that go from in this little box up to the switch and back and connected to the motor again. Based on the, red, brown, line to switch, yellow, black, line to switch. So, and we got a belt that's not super tensioned, but it's at least there. And we push a button and it starts. We push a button and it stops. And it spins. Now the only thing I don't know is if it's spinning the right direction. The good news is if you reverse this, if I find that it's spinning the wrong direction, I can go in and reverse which set of wires is connected to what. But this barely reaches with the way it's currently stretched. It's not super stretched, but it is stretched. Yeah, it's up near the paint on the post. So, yeah, we probably could pull it just a slight bit more back, but there's not a whole lot more slack on this. So I think if I need to tension it more, I'll have to take some more, or one or more links out, pull it back in, and then go again. But it seems that as soon as you push this at all, it stops. But that's cool. Yeah, and it definitely doesn't, it's heavy enough that it doesn't make a jump at all. It just turns on and then turns off. Whereas the blue one over there, that one, when you turn the switch on, the whole thing jumps, but then it's fine. So I think this is going to work because it looks like it's running this way. Because if it's pulling this direction, well, I could also just have the belt on backwards, but I think this is the same way that the other drill press is set up. But this, if it pulls in this direction, that means it's pulling tension on these tabs. So it is pulling tension on the tabs. So hopefully I got it right. I obviously can't test it yet because I don't have it. It's horizontal, and I really don't want to hold a board up against a drill bit and see if that's spinning correctly. Let's see. So that is going this direction. So that is going from the bottom. That's going counterclockwise. So let's go look and see what the other one does. That's spinning this way, so from the bottom, counterclockwise. I think it's actually correct. Yeah, so cool. All right, well, that's good. You get to see all the mess. That means theoretically, once I figure out stuff and such, yeah, that's very cool. So, yay! My motor adapter. And this is not moving at all, so it's holding nice and steady on there. So I guess now the only thing, since I think it's turning the right way, the only thing left is to finagle the motor tension. But that's cool. So yay, I actually wired it correctly. I wasn't sure, but I just took it step by step and slow. And I have a ground coming from the plug up. That's going into a junction where a wire goes from there to the box and is grounded to the motor. And then another wire comes through here, and it's actually grounded inside here on one of the screws that's holding it to the frame. So that should be sufficient ground. I don't know that it matters, and I can always take it apart and redo it, but I think the black wire comes in. So I have a black wire that comes in there, black wire that attaches, comes in through here, up, and because I wasn't paying attention, I attached it to the top of the switch, not the bottom of the switch. And then there's a red wire that goes from the bottom of the switch back and connects to one of the motor leads. That would go to the black and yellow wire lead. And then the white wire comes in, and that attaches to the red wire and brown leads. So I'm not 100% sure if it matters, but if it does, because it's a switched thing and nobody's ever going to hopefully open this, but if it does matter which end, because this is an ancient thing and I don't know which way it was input before, just had tan on the bottom and black on the top, and since it was just all open, it wasn't actually attached. I'm not sure, but in any case, if I decided to change that, that'd be one thing, and then belt tension would be another, and a belt guard would be a third. There was a hacked up belt guard that came with it, just a piece of sheet metal, so I have to figure out what I'm going to do with that, if I'm going to try and use that or not, or try and make something that's a little more rounded and matches the profile of the front. I haven't decided on that, but that's cool. It turns on, it turns off, and it doesn't jump. So that means it's heavy enough that it doesn't jump, and or the motor is smooth enough that it doesn't jump. So yay, progress. So that's it for this. I'm probably going to make a video out of this and then figure out the paint and other things and the table and such for probably a follow-up. But that does not get old. That is awesome. That's very cool. Very, very cool.